In this lesson here, we're going to take a look at using trig ratios to solve for a missing angle. We're going to specifically look at when we have not just tangent ratio. So I kind of went over the tangent ratio in a previous lesson. And so in this lesson here, we're going to look more at the sine and cosine ratios and how that works. We're also going to take a little dive or a little look at angle of elevation as well as angle of depression. So that's what we're going to cover in this lesson right here. So I'm going to start off with that angle of depression, angle of elevation, and what they represent, what they mean. And so I want to start off with taking a look at sightline. And I want you to think about when you look at something, you look straight on your sightline. Where are you looking? Are you looking up? Are you looking down? Are you looking straight? And if we're looking, the sightline that we're going to talk about is where we're looking and the direction that we're looking at. So a normal sightline, okay, and this is what we're going to just consider normal, everyday, straightforward, is when you're looking straight. Okay, so when you're looking straight at something, you're not looking up, you're not looking down, you're looking straight at something. That's going to be what we consider a normal sightline. So here's our normal sightline. There's an eye, and then I have that yellow line representing the sightline that we have. Okay. We can also call this the horizontal. It's another way of representing a sightline. It's parallel to our ground. Okay, so that's the sightline we're talking about. It's a nice horizontal line. There's no angle up, no angle down. Okay, and that's something we're going to look at as well. So here is our normal sightline. Now, if someone is looking up or down at something, they are looking at an angle to the horizontal. So you'll notice that horizontal line that is, again, still straight there. And if someone looks up at something, well, they are looking up at some angle. Okay, there's an angle that they've changed their gaze to look up. If I look up, okay, I have changed my angle looking up. If I look down, I'm doing the same thing. I'm looking down at some angle. Okay, because these two sightlines are straight, okay, the angle between them can be measured, and we can measure that angle that we have. So I'm going to just take a look at two sightlines that we have here. So I have two sightlines, they're parallel lines. One is up higher, one is lower, and that's kind of what we're looking for here. So when we have a sightline that is below the horizontal, so we're looking down, what we say is that we have an angle of depression or declination. You can use whatever way it helps to look at those two words. But we have an angle of depression. Okay, we're depressing our angle that we're looking at, or a declination, it's a decline. Okay, either one of those words works. You might see both of them in different kinds of questions. So depression, to depress, right, to go down, or declination, to decline the viewing angle that we might have. The other side is if we're looking up. Okay, if we're looking up, okay, we have an angle of elevation, or to elevate our gaze, or an incline or inclination. Okay, so elevation or inclination means to look up. Now, the angles that we're looking at, and you can see on the screen there, we have an angle from the horizontal down, okay, so that's above, or an angle from the horizontal up, which is above the horizontal, and that would represent our angles of inclination or declination, or elevation or depression, are two ways that we can think about it. Now, when these two sightlines are connected, as you'll notice in the picture here, so the person on the bottom is looking up at the person on top, and they have that angle. Let's go here. There we go. Okay, that angle, they're looking right at each other. Okay, think of if you're, someone's a little higher and someone's a little lower, and you're looking straight at them. These angles are equal. If I am standing, so an example I usually give is I stand up on a chair and I look down at people that are sitting on the chairs. I am looking down at the same angle that they are looking up. It's just they're looking up and I'm looking down. So my angle is an angle of depression and theirs is an angle of elevation. And so that's just kind of what we use when we talk about our sight lines. So it's very important that we recognize these two here. And I'll go through an example in a little bit of where, how we can determine these angles and what these angles look like. All right, so let's now do some examples with right angle triangles and trying to figure out a measure. Like I mentioned in the previous lesson, I went over the tangent ratio and how we can use that to find the ratio, as well as how we can use the ratio to find the angle. Um, in this lesson here, we're going to go through a couple other ones, and we're going to look at the two other ratios that we can use. The second ratio that we're going to use here, so first is tangent. Second one is sine ratio, S-I-N-E. We simplify it to sin, or S-I-N. I still say sine every time, but it's going to be our sine ratio. This ratio, again, uses the opposite and hypotenuse as references for the ratio. Remember, tangent used opposite and adjacent. This time, we're going to use the opposite and the hypotenuse. The sine is an operation again, which converts an angle into a ratio, just like the tangent was. And on your calculators, you can gladly take a look and see if you can find the sine button. Usually it's very, very close to the tangent button as well. So our sine ratio looks like this. Sine of our angle is equal to opposite over hypotenuse. So if we take the sine of the specific angle we're given, it's the same as doing the opposite side divided by the hypotenuse side. And that will give it to us. If we want to find the angle, we can do the inverse sine. Remember, that's that second function button that we've talked about. It's usually the sine button, but with second function. And it's still the same. We do the second function sine of opposite over hypotenuse. Again, if you're unsure of how to use this calculation or unsure how to do it in a calculator, please ask somebody, whether it is your math teacher, whether that's me or somebody else, and or somebody who maybe has done this before as you practice. We'll do a few examples in this video here, and you can see if you're getting the right answers. If you're not, then we'll have to check with somebody as to how to use your calculator. The third one that we're going to take a look at is the cosine ratio, or cos. Again, this button will be on your calculator. It'll be right beside or very close to your sine and your tangent button. This ratio uses adjacent and hypotenuse sides of the triangle, so we've kind of covered all combinations that we possibly could. And again, just like tangent and sine, cosine is an operation which converts an angle into the ratio. So it takes the angle and it converts it into the ratio, and likewise we can take the adjacent and hypotenuse sides and figure out what the ratio is as well. All right, the cosine ratio looks like this here. Cosine of theta is equal to adjacent over hypotenuse, and we can use inverse cos as well to determine what the value is of that angle if we're trying to find that. Okay, here we go. Let's take a look at some examples. We're actually going to use similar examples to what I used in the tangent video, if you've seen that one. But this one here, we're going to look at, can we find the sine and cosine ratios of this triangle? And we're going to find both of them, even though we would normally not have to if we want to find an angle. We're just going to go through the practice of finding both of those ratios. So again, in this example time, if you want to pause the video each time I introduce an example, and then try to solve for it, and then restart it again and determine did you get the correct answer, either by yourself or with a partner. So here is, so you can pause it, and welcome back. We want to try to figure out what is our sine ratio and what is our cosine ratio for this triangle. Very first thing that we always have to do is label the triangle. Okay, every time we have to label. Hypotenuse again is our long side, and then our adjacent and our opposite are related to the theta, or related to the angle that we're trying to find. So let's see here if we can. No, it's going to be hard for me to guide with my hand there. When we're taking a look at the sides, the hypotenuse again is the longest. The adjacent side or adjacent leg is always touching the angle. So you'll see that theta is attached to the 15. So that's our adjacent side. And then our opposite side is the 8. Now for our sine ratio, we're doing the opposite over hypotenuse. So we're going to take the opposite side, which is 8, divided by the hypotenuse, which is 17. And we get a ratio of 0.470588235. Now, if you want to round it to about 2 or 3 decimal places, that's totally fine. For an assignment, that's what I would ask for. But when we're actually trying to find the angle, we want to try to keep as many decimal places as possible. Cosine has a different ratio. It is the adjacent over hypotenuse, so it's 15 divided by 17. and that gives us 0.88 and then a bunch of decimal places. You'll notice these are two different ratios because they are involved with two different sets of sides. It also means that we need to use a different function, either sine or cosine, to find the angle measure for these two combinations. The crazy thing is, and we'll get into this in a little bit, no matter which one you use, you would get the same angle. Okay, it works. Okay, if you take the inverse sine of 8/17, you're going to get an angle measure. If you take the inverse cos of 15/17, you're going to get the exact same angle that you did in the previous example. All right, let's try another one. Okay, gladly pause the video. And welcome back. Finding the sine and cosine ratios for these here. Again, first step, always have to do, label the triangle. Okay, make sure that you have it properly labeled, especially on like an assignment or a test. If you are being asked to do this and then someone needs to see how you've done it, make sure you've labeled the triangle so that we can see if there was a mistake in your labeling, and that's why you got a mistake in your answer, or if the mistake was somewhere else. So sine ratio, opposite over hypotenuse, 35/70, 37. Okay, it gives us a ratio of 0.945 repeated. You can always just leave it as a fraction as well. That totally works, or you can put it into a decimal form. Cosine ratio, adjacent over hypotenuse, is 12/37, which is 0.324 repeated in this case here. All right, so that's coming up with those ratios, the sine and cosine ratio. And finding the decimal place will be a small part of what you're asked to do. But what we're really going to try to do is, like our next one, we want to figure out what is the angle measure for whatever. In this case, we're trying to find angle R. So gladly pause the video, try to solve for angle R using what you already know. And if you're unsure, gladly keep watching, but you can pause now. All right, welcome back. So we're going to try to find the angle here using one of our ratios, and it's important to try to figure out now which ratio are we going to use. We have three ratios that we know. We know our tangent ratio, we know our cosine ratio, and we know our sine ratio, and one of those three is going to be helpful in solving this exact question. So step number one, always step number one, label our triangle. So label the hypotenuse, the opposite, and the adjacent side. And this will then help us to figure out which ratio we're going to use. All right, which sides do we have? Well, we have the opposite side, the hypotenuse, and we don't know the adjacent. So to find the angle, we are going to use the ratio that has opposite and hypotenuse in it. That ratio happens to be our sine ratio. Okay, sine uses opposite and hypotenuse. We don't need to use Pythagorean theorem to find the adjacent. It's not necessary. We have a ratio that we can use to find our theta. Plug in our value, okay, 7 and 25. Do the inverse sine of this, and you should have gotten an angle of 16.26 degrees, or you could round it to the nearest degree, and that would be 16 degrees. Let's try another one. Find angle X. You can pause the video now. All right, welcome back. Step number one, label the triangle. Okay, your opposite, adjacent, and hypotenuse sides. In this case here, we have the adjacent and hypotenuse. So we're not going to use the sine ratio this time. We're going to use the cosine ratio this time because it involves adjacent and hypotenuse. Plug the values in, 8 and 10, and you should get an answer of about 36.87 degrees, which rounds to 37 degrees as an angle. And again, we're often going to round just to the nearest degree, different from a lot of other things, but I'm going to ask you to round to the nearest degree. If you have a different teacher, you might be asked to round to something different. All right, let's do a word problem. We have a bird that is sitting 13 meters above the ground in a tree. 45 meters away from the tree, Mr. Barkman is looking at the bird. What is the angle of elevation Mr. Barkman is using? All right, pause the video, draw a diagram, and determine what the angle of elevation is. Welcome back. I'm going to draw out my diagram. So here we go. We have a bird in a tree. Now, that's a pretty fancy one. I found that as a clip art on the internet. Same with a picture of me. Okay, that's not me. You can see me in the video here. But this just gives us a little bit of an idea of our diagram. So We know that the bird is 13 meters above the ground. That's going to be straight line, perpendicular to the ground. And that distance on the ground is 45 meters away. The question we're asking is, what is that angle right there from my sight line to the horizontal? Step number one, as always, well, so step number one was really drawing the diagram. Step number two now in this case is going to be to label our triangle. Now I don't have a right angle in that triangle, but we have to assume that there is. And so we have our opposite, adjacent, and our hypotenuse sides. The right angle will always be with the ground, as the ground is flat, or at least in theory it is flat. And in this case here, I have the adjacent, I have the opposite, I don't have the hypotenuse. So which function can we use to solve for theta? Well, adjacent and opposite, that would be our tangent ratio, which we're going back to the previous lesson on. But we can use our tangent ratio as well because we have the opposite and adjacent. We don't need to use Pythagorean theorem to find the hypotenuse because we have that theory already, or we already have a function for that. All right, so angle is going to be about 16 degrees or 16.11 degrees. So we can say that Mr. Barkman is looking up at a 16-degree angle and looking at the bird at that angle. All right, let's do another word problem here. So we have a 16-foot long ramp. Okay, the ramp is 16 feet. It's placed from a deck to the ground. The deck is 1.5 feet above the ground. What is the angle of depression going down the ramp? Draw a diagram. Determine what the angle of depression is of this ramp. And welcome back. I'm going to draw a diagram as well, so let's get rid of that. Let's draw out our ramp, which is 16 feet long. It is 1.5 feet off the ground, so that means that there will be a right angle there. And we're looking for this angle of depression. All right, okay, angle of depression is above. And you might be like, well, I don't see it there. Where can we do it? Understand too that the ground and the horizontal are equal to each other, which means that the angle of depression is exactly the same as the angle of elevation, and therefore we can solve for that. All right, so first thing we need to do now, once we have the diagram, is we need to label this diagram with hypotenuse, opposite, and adjacent sides. Okay, when we do this here, okay, we know that we have an opposite and hypotenuse side. So to find the angle of depression, which is also the angle of elevation, we are going to use our sine ratio. And so we plug the values in and we get an angle of 5.38 degrees, which is the same as or rounds to about 5 degrees. Okay, so this ramp has an angle of depression of 5.38 degrees, which is also the angle of elevation. Now, second part. Code states that a wheelchair ramp cannot exceed an angle of depression of 5 degrees. Is this ramp legal? Okay, based on what we know. Is this ramp okay? Can we use it? No, it's too steep. Okay, and just by a tiny bit. But it is too steep. It's above the 5-degree threshold. So we have to make sure to keep it. We can't use it as a ramp. It has to be a little bit longer or a little bit lower that we can use it. All right, I hope this helps you with going through some examples of how to solve for angles using specifically sine and cosine, but we can also use tangent as well, and making sure to draw diagrams as we look at the type of question we might have in a word problem. Thank you very much for watching, and all the best as you do your work.